Did you know your favorite spices are actually plant poisons? Yes, you heard right. Did you know that the most delicious flavors humans have ever discovered were never meant for us at all? The cinnamon in your coffee, the pepper on your eggs, the heat in chili peppers, the warmth of ginger, the sharp bite of garlic. They evolved as chemical weapons. In fact, many of the spices sitting in your kitchen right now were designed by plants to poison, burn, paralyze, or kill whatever tried to eat them. So why do humans crave them? Why did entire empires rise and fall over them? And how did something meant to repel predators become the foundation of global cuisine? Today, we're uncovering the strange biological truth behind spices and revealing how humanity turned plant poison into pleasure. So let's explore how spices are plant defense chemicals. To understand spices, you first need to understand one simple problem. Plants can't run. They can't flee from insects. They can't escape grazing animals. They can't move away from bacteria, fungi, or parasites. So instead, plants evolved chemical defenses, substances that make them painful, toxic, or lethal to consume. Scientists call these compounds secondary metabolites. Unlike sugars or proteins, which help plants grow, secondary metabolites exist for one reason only: survival. These chemicals can damage nervous systems, burn sensitive tissues, disrupt digestion, kill microbes, repel insects, poison mammals, and what humans call spices are simply these defense chemicals, consumed in small, controlled doses. Spices are not flavorings. They are signals. To most animals, these compounds send a clear message: do not eat this. But humans learn to interpret those signals differently. Let's look at the evidence. Now we look into the science behind specific spices as poisons. Chili peppers. Capsaicin, a mammal deterrent. Chili peppers contain capsaicin, a compound that activates pain receptors in mammals. Capsaicin does not cause heat. It causes pain by tricking your nervous system into thinking it's burning. For mammals, this is unbearable. For insects, it disrupts cell membranes. For fungi, it slows growth. But birds? Birds don't feel capsaicin at all. This is not an accident. Chili plants evolved capsaicin specifically to stop mammals from destroying their seeds, while still allowing birds to eat the fruit and spread the seeds intact. Humans, uniquely, learn to enjoy the pain. Black pepper. Piperine, an insect neurotoxin. Black pepper's bite comes from piperine, a compound toxic to many insects. Piperine interferes with nervous system signaling, making it harder for insects to move, feed, or reproduce. It also discourages mammals by causing irritation in the mouth and digestive tract. Yet humans made pepper one of the most valuable substances in history. So valuable, it was once used as currency. Cloves, eugenol, nature's antifungal weapon. Cloves are rich in eugenol, a powerful antimicrobial and antifungal compound. Eugenol damages cell membranes and proteins in fungi and insects. At high concentrations, it is toxic, strong enough that it is still used today in pesticides and antiseptics. To the clove tree, eugenol is armor. To humans, it's holiday flavor. Cinnamon, cinnamaldehyde. Chemical warfare in bark form. Cinnamon's smell comes from cinnamaldehyde, a compound that kills or inhibits bacteria, fungi, and insects. It evolved to protect the tree's bark, one of its most vulnerable tissues. This same compound is now studied for its antimicrobial properties in food preservation. What smells warm to us is deadly to microbes. Garlic. Allicin, a chemical trap. Garlic is especially clever. When intact, garlic is harmless. But when crushed or chewed, enzymes convert compounds into allicin, a toxic chemical that attacks bacteria, fungi, and parasites. This is a built-in booby trap. The moment something tries to eat garlic, the poison is released. Humans learn to crush it on purpose. Nutmeg, myristicin, a poison we use carefully. Nutmeg contains myristicin, a compound toxic in high doses. In large quantities, it can cause hallucinations, nausea, heart palpitations, and even death. Historically, Nutmeg plantations were so valuable that wars were fought over them, despite the fact that the spice itself can be dangerous. This is a reminder: spices are only safe because humans learned dosage. How? Why humans love what other animals avoid? So why do humans enjoy plant poisons? 1. Humans can detoxify small amounts. Our liver is exceptionally good at breaking down low doses of toxins. What kills an insect barely registers in a human body, especially when cooked or diluted. 1. Spices kill foodborne bacteria. Long before refrigeration, spices acted as natural preservatives. They killed microbes that caused food poisoning. This is why cuisines in hotter climates tend to use more spices. Heat accelerates spoilage, and spices offered protection. Flavor was a side effect. Survival was the benefit. 1. Pain and aroma trigger reward systems. Capsaicin releases endorphins. Aromatic compounds stimulate memory and emotion. Humans learn to associate controlled pain and strong aroma with pleasure, excitement, and culture. We turn biological warning signs into sensory experiences. 1. Spices changed human history. These plant toxins shaped global trade routes, colonial expansion, the rise of empires, entire culinary traditions, all because plants were trying not to be eaten. Now, why this matters today? Every time you season your food, you're participating in an ancient evolutionary negotiation. You are tasting chemicals that once meant danger. You are enjoying compounds designed to repel life. You are benefiting from millions of years of plant survival strategies. Spices are not just flavor. They are history. They are biology. They are warfare turned into art. Nature built them as poisons. Humanity turned them into culture. And now you'll never look at your spice rack the same way again. If you enjoyed this, please give us a thumbs up, and don't forget to share with your friends. Go ahead and hit that subscribe button for more.